will be looking at problem number 31, which shows a pulley system where block A rests on a horizontal surface and block B hangs vertically. First, we will write the givens, which are that the mass of A is 10 kilograms and the mass of B is 5 kilograms. Next, we will define a coordinate system. So up is positive and right is positive. And force of gravity is 9.8 meters per second squared. But since it is in the downward direction, it is negative. We will then draw free body diagrams for block A and block B. And for the forces that are acting on block A is the force of gravity, and there is the F norm, which is the opposite force because it's from the surface it is resting on. And the last force is tension from the rope. We can find the force of gravity using the equation force of gravity equals mass times the acceleration, or gravity. So we plug in 10 kilograms for the mass and negative 9.8 meters per second squared for the acceleration. So the force of gravity on block A is negative 98 newtons. We can then use the net force as it equals 0 and set it equal to the force of gravity plus the F norm. So since force of gravity is negative 98 newtons and F net is 0, when we plug it into the equation, F norm equals positive 98 newtons. Now we will be drawing a free body diagram for block B. So the forces acting on it are force of gravity and force of tension from the rope. We will use the same process as before to calculate force of gravity by plugging in 5 kilometers for the mass and negative 9.8 meters per second squared for gravity, and we get the force of gravity equals negative 49 newtons. We can then use the same process of setting up F net equal to 0 to calculate force tension of the rope. So 0 equals force of gravity plus force tension of the rope. And since force of gravity equals negative 49 newtons, the force tension equals positive 49 newtons. And since the rope is attached to both of the blocks, as block B moves down due to gravity, it pulls on the rope, and block A moves with the same amount of force as block B. So the force tension on both blocks are equal, and it is 49 newtons. Now we will use Newton's second law to find the formula for acceleration of the system and the tension in the rope. We will be ignoring friction and the masses of the pulley and cord. Newton's second law is force equals mass times acceleration, and we can use the net force and the mass to find acceleration. So by rewriting the equation isolating acceleration, we get A equals net force divided by mass. There is no friction, and since block A does not hold block B from moving, we can use the force of gravity on block B as the net force, which is negative 49 newtons. So mass equals both blocks since they are part of the system, which is 15 kilograms. So to calculate the acceleration of the pulley system, we take the mass of both blocks, 15 kilograms, and the net force, which is negative 49 newtons, and plug it into the equation to get the acceleration, which is negative 3.26 meters per second squared.